Today we are working on our last lesson in our second space unit, and it's about space junk. Well, what do I mean about space junk? I'm talking about comets, meteorites, asteroids, things like that that are flying around in space close to us. We're starting with comets. Comets are just a loose collection of ice, dust, and rock that orbit a star. Basically, think of them like a dirty snowball. You need to draw a picture of a comet on your note sheet, so go ahead and do that. The center part of the comet, okay, so draw a circle maybe, is the nucleus. In front of, and we talk about in front of, and we're going to talk about how that doesn't really make sense, but in front of it, you have a coma. A coma is a little bit of gas and stuff in front of it. Now, I'll draw my nucleus here. So my coma is going to be this little bit in front, and then I'm going to go out and draw my tail, shooting out the back. And again, front, back, it doesn't really make that much sense when we talk about comets, and we're going to get into that. Notice there are two tails. Dust tail, obviously dust, plasma are the charged particles, so it's a little bit different, and we can see that in some of the pictures. So where do these comets come from? Most comets originate in the Kuiper belt or in the Oort cloud. Well, where's the Kuiper belt? The Kuiper belt is just beyond Neptune. So you see the solar system here, the sun is in there, all the inner planets. We get out to Neptune, and then Pluto's this one. This is the Kuiper belt. So lots and lots and lots of comets are out here. They may get knocked off their orbits because they orbit too close to each other, something goes through, whatever. They get knocked out of orbit, they come cruising closer to the sun maybe, and then we get to see them. There are even more in the Oort cloud. Okay, the Oort cloud probably has billions of comets. The Oort cloud is really far away. It's over 1,000 times the distance from the sun to Pluto beyond Pluto. Okay, so think go to Pluto and go 1,000 times more of that distance. And this picture really shows it. So this whole picture here, Pluto's orbit, sun, everything like that, that would go right down into this tiny little part. And then the Oort cloud is way out from that. Billions of comets there. Again, they may get knocked out of orbit somehow, and then they start flying around, and they could endanger us. Comet tails. Comets don't always have a tail. They only have a tail when they get close enough to the sun to melt. Remember, they're like a dirty snowball. So if they get close enough to the sun, they get hot, that ice melts, and then it produces the tail. So in this picture you see that only when it gets close enough to the sun does it melt. So we could have a comet coming towards the Earth and not even know about it until it's too late, until it gets, basically closer than Mars's orbit. Then it gets hot enough and it melts, it gets a tail, now we can see it. Another thing with the tail, you see in this picture, the tail always points away from the sun. The sun is giving off its energy, it's giving off its heat, it's giving off solar radiation, and that blows the tail away from the nucleus, always in a direction opposite from the sun. So that's when I said, the tail's behind, the coma's in front. Well, no. Not really. Just because if I draw my comet like this, let's say, does that mean the comet is going this way? No, not at all. All it means is that the sun is this way, because the solar winds, heat, and everything is going that way, blowing the tail out that way. The comet could be going this way, it could be going this way, it could be going this way. Okay, the tail could be leading the comet, that happens. So the tail doesn't tell you which way it's going, it only tells you where the sun is. So you'd need to watch the comet for a few days or a few months, and then you could see where it's going. And this picture does a good job of showing that. The tail always points away from the sun. Our next particle of space junk are asteroids. Asteroids are small rocks that orbit a sun or star, also called minor planets. A lot of them are in the asteroid belt. Where's the asteroid belt? It is between Mars and Jupiter. Okay, so it's between the orbits of Mars and Jupiter. A lot of scientists think it's the material that should have formed another planet, but because of Jupiter's gravity was so strong, it never let all of this material come together and form another planet, so it just remained as part of the asteroid belt. Next up are meteors, meteoroids, and meteorites. They're all three basically the same thing. The only difference is their location. A meteoroid is a chunk of rock or dust in space. Meteor is that chunk of rock or dust as it's going through the atmosphere. Then a meteorite is that rock or dust that has hit the Earth or some other planet, moon, alright, some other body. So meteoroid in space, meteor in the atmosphere, meteorite has hit. Once the meteorite hits, it leaves behind a crater. Okay, I'm sure you know this. This is Meteor Crater, or the Barringer Meteor Crater in Arizona. It's a really cool place. It's huge. You can see the road that goes into it, and the visitor center is up here. It's not very far off of I-10, so if you ever cruise out that way, you can take a little jog out and go walk around the top of Meteor Crater. And I have some pictures that I'll show you in class and talk a little bit more about it. It's pretty impressive, and I have some meteorites that I'll show you in class also. Why do meteors burn up in the atmosphere? Well, first, they don't actually burn up in the atmosphere. They just get really, really hot, and it's because of friction. Meteorites are moving really quickly, 40,000 miles per hour, maybe 45,000 miles per hour. They're going really fast. Because they're going so fast, the air is rubbing against them. There's lots of air rubbing against them, and that makes lots of friction, and it makes them very hot. Okay? So a shooting star is just a meteor that's getting really hot because it's going so fast through the atmosphere. Are there lots of meteoroids near the Earth? Yes, there are. So let me show you this. This is showing you kind of real time today, okay, October 2nd, 2013, when I was making this, of all the different meteoroids that we are currently plotting. And we're plotting them because they could endanger the Earth or a spaceship or a satellite. So we need to plot all these. So each dot is a meteoroid of some sort. The star there in the front, that's the Sun. Mercury, you see, is right there. Venus is, I don't even see Venus, it's somewhere in here. Then Earth is right there, that circle. Mars, I can't really spot right off the bat here either, but Mars is somewhere in there. And then we go Jupiter here. So this is plotting all the different things. The dots that are red, those are meteoroids that get within 1.3 AU. Okay, that means an astronomical unit in AU is the distance between the Earth and the Sun. So basically they get close enough to us, closer than the Sun is. Okay, they get close. Some of them might be really far out here. It just means they have a really oval orbit. The green ones are ones that don't get as close. But again, we still need to track them because we have probes and other things that are flying out through the solar system. Now, is this all of them? No. There are probably lots and lots of them, at least as many as this, that we don't know about. These are just the ones that we know about. It's the ones that we don't know about that scare us, because we can't see them. Even one that's just as big as half a mile would do serious damage to the Earth. And you're going to learn about that in a video. We're not going to talk about that much here. So you have to be aware. This is plotting things basically that are bigger than a pencil eraser. So some of these are very small, but something the size of a pencil eraser, that's big enough to destroy a space shuttle or a space station. Okay, it's not big enough to do anything to the Earth. They would burn up in the atmosphere, so not endangering the Earth, but they do track them because, like I said, if they could hit a satellite, they could hit a space station, so definitely need to be tracking them. Meteorite impact, again, we're not going to talk about this much here because you're going to be watching a video that's going to talk about a meteorite hitting the Earth. Basically, a large meteorite hitting the Earth, like I said, half a mile wide or bigger, is complete disaster for the whole Earth, not just where it hits. And it'll talk about why. Doesn't matter if it hits on land or in water. No, it really doesn't. When you think about it, if a meteorite, maybe let's say a mile wide, is hitting in the ocean's not all that deep. Okay, the deepest part of the ocean is like, what, 6.2 miles? Most of the ocean, you know, a mile is, a lot of the ocean is shallower than a mile. So it's really not going to stop it at all when it's traveling, like I said, 40,000 miles per hour. The ocean doesn't really matter. So like I said, the video is going to talk about what happens, or what would happen if we got hit by a large impact. What killed the dinosaurs? Well, we think that was from a large impact. And again, I'm not going to really go through this now. It's on the PowerPoint if you need to see it. We're going to see this in the video also. But I do have it on the PowerPoint here. You can see that we think, and again, I underline theory, this is what we think is right now, but it might not be. Okay? It might be a combination of this and some volcanoes that erupted on the Deccan Flats or some other places. So probably a combination of things, so definitely still a theory. And you can see how big it was, how fast we think it was traveling, where it hit Chicxulub, okay, in the Yucatan Peninsula, and you can see what happened. Basically, it heated everything. It heated the atmosphere, and then cooled it because it blocked out the sun, and then raised it again because of greenhouse gases. So a big kind of flip-flop. If you weren't killed immediately, then many things were killed because they couldn't handle this climate change. And shows some evidence and some controversies. Like I said, you can look at that later. So what are we doing to try to prevent these things from hitting the Earth? Well, we are definitely doing some things. Space Guard is a UK site, and they are, as it says, they're the leading organization in the United Kingdom dedicated to the promotion of British participation in the growing international program to detect Earth-crossing asteroids and comets and to protect the Earth from potentially catastrophic collisions. So yes, we do have some plans to try to save the Earth, and Space Guard is one of the main ones, and they talk about all the different projects on here, and they have some school things. It's kind of neat. And I put some of these programs on the PowerPoint here that we can talk about. Realize, though, that there are some things maybe that we can do. The idea, though, that you see in the movies of blowing them up, that is a bad, bad idea. We do not want to blow anything up in space. If we do, then there's going to be lots of little pieces that will rain down on top of us and heat our atmosphere and cause the impacts and just destroy us anyways. If we do blow it up and they don't hit us, then we have maybe thousands of more pieces out there that are going to destroy space stations or probes or come hit us later. So the key is we want to deflect them. Okay, we don't want to destroy them, we want to deflect them. And there are lots of different options that people have come up with. A tugboat idea is pretty simple. You have a little spaceship, you hook on to the Meteoroid, and you push it away. You don't have to push it very far if you get it ahead, long enough ahead, a couple years ahead. The Don Quixote mission, you haven't read this book yet. It's a pretty good book. You'll read it in upper school probably. Basically, it consists of two probes, Hidalgo and Sanchez. Sanchez starts orbiting the meteoroid. Hidalgo goes on a suicide mission and smashes himself into it, trying to push it away, change its orbit. If it was successful, well, then Sanchez just follows it for the rest of eternity, essentially, radioing back to us what position it's in, making sure that it's not endangering us in the future. If Hidalgo doesn't knock it away far enough, then Sanchez can come in and suicide mission and do that. Again, obviously no people in these things, right? Ready to go by 2029, we think, the European Space Organization. Nuclear deflection, again, we're not blowing it up. What we're trying to do is just deflect it. And let me see if I can get this going again. There we go. So you blow up your nuclear bomb kind of before it, and Newton's third law is going to push that away. And again, you don't have to push it much as long as you get to it early. Focused solar energy, so basically a laser beam hitting it. It'll provide a little bit of impact over time. Also, it will basically blow up some little pieces, Newton's third law, again, that's going to help propel it away. Wrapping it in plastic and white paint, similar idea. You change the color, more sunlight will reflect off of it instead of being absorbed. Again, Newton's third law, that's going to start pushing it away. Again, very, very slowly. You need to get ahead of time. Solar sail, attach solar sail, help it to pull it away. You could just simply park a ship next to it and let the gravity slowly pull it away. Okay, so lots of ideas. Blowing them up is not one of them, but lots of ideas that we could do. Problem is lots of money, who's going to pay for it, and will we know enough ahead of time to do something about it? If it gets closer to us than the moon, it is way too late. We need to get notice of these things, like I said, hopefully years in advance, and then start doing something with them. And that's it for Space Junk.